In modern supply chain management, we spend a massive amount of time optimizing how goods move forward to the customer. But under the APEX and ASCM frameworks, there is an equally rigorous discipline for what happens when goods move backward: reverse logistics. Imagine a sprawling distribution center, but every package on the belt is swimming upstream, moving away from the consumer. For a long time, operators treated these reverse flows as ad hoc nuisance events, an annoying cost of doing business. But that perspective leaks money. Today, we must approach reverse logistics as a strategically designed discipline. It requires the same level of planning and control as the forward supply chain. The primary purpose of building this architecture is to recapture economic value. That means intelligently routing products for reuse, refurbishing, or remanufacturing before they lose their worth. Beyond pure value recovery, a highly tuned reverse network reduces your total landed supply chain costs and ensures strict compliance with environmental and disposal regulations. By managing these flows systematically, companies protect their brand trust and lay the required groundwork for modern circular economy sustainability goals. To build this system correctly, we have to start with the formal APEX definition. Reverse logistics is the process of planning, implementing, and controlling the efficient flow of materials. Specifically, it governs the flow from the point of consumption back to the point of origin, and it is executed for one of two explicit purposes: recapturing value or ensuring proper disposal. In many organizations, operators mistake reverse logistics for customer returns management. The two are distinct. We have to separate the process from the event. Returns and recalls are simply triggers. They are the events that activate the reverse logistics system. A return is a service-driven event. It is usually initiated by the customer because of dissatisfaction or a defect, which means the inbound volume is inherently uncertain. This diagram illustrates a standard return process. The operational steps here, like free shipping, clear policies, and label printing, are designed entirely around customer service and commercial friction reduction. A recall is entirely different. It's a risk-driven event focused on safety hazards, legal exposure, and regulatory compliance. Cost is secondary to risk mitigation. This graphic maps the distinct stakeholders in a recall. Unlike an optional return, a recall forces mandatory interactions between government agencies, manufacturers, and consumers, usually triggered by a central safety hazard. So, returns represent a customer's choice, and recalls represent a legal obligation. Reverse logistics is the overarching physical and data architecture designed to process both of these events. Once an event triggers the system, the product enters a highly structured physical network. This flowchart maps a product's life cycle, moving backward through a reverse logistics cycle, from the consumer to raw materials. The journey begins on the right. When a used product leaves the consumer, it flows downward into the first major operational node. This is the test stage, the critical triage point where operators inspect the item and make a routing decision. Products in good condition are routed to repair and refurbishing, bypassing complex manufacturing and pushing straight back into distribution for resale. If the product requires invasive work, it drops to disassembly, entering the remanufacturing stage, which routes back to manufacturing. Further down is recycling, where the product is broken down completely, returning its core elements to the raw material stage. At the absolute bottom is disposal, non-recoverable waste providing zero economic return. Notice the dashed arrows across the top. Even before reaching the consumer, unused products and excess packaging can instantly become waste and enter this reverse flow. The governing rule of this hierarchy is simple. Maximum economic value is retained the closer a product stays to its original finished state. Every step down the chart costs money. Managing this hierarchy is difficult because it inherently operates against the natural flow of traditional logistics. Forward supply chains are optimized for bulk downstream delivery. Pushing a package upstream through a facility designed for outbound freight creates immense physical friction. Operators also deal with severe uncertainty. In forward logistics, you know exactly what is on a pallet. In reverse logistics, the volume, quality, and arrival timing of incoming goods vary wildly. Because these flows are fragmented, processing them requires deep cross-functional integration between customer service, warehousing, and finance. To manage this friction, APEX relies on three operational principles. The first is systems thinking. Systems thinking dictates that reverse and forward flows are interdependent. If you expand your forward supply chain capacity without planning for the resulting returns, you will immediately constrict the parallel reverse flow. The second principle is cost-to-serve logic. This requires strict inventory segmentation. You cannot spend $50 processing the return of a $10 item. Low-value goods require automated or entirely distinct processing paths compared to high-margin products. The third principle is design for recovery. The efficiency of a reverse supply chain is actually determined during R&D. The initial product architecture ultimately dictates how fast and how cheaply an item can be disassembled at the end of its life. We see these principles applied differently across industries. In retail, the focus is on structured returns management to get inventory back on the shelf as quickly as possible. Contrast that with heavy manufacturing and the automotive sector. Their reverse networks are built around core returns and rigorous parts refurbishment programs. In electronics, the reverse flow is dominated by e-waste handling and maintaining strict compliance with hazardous material regulations. Across all these sectors, operators face two primary challenges: exorbitant transportation costs for single-item shipments and extremely poor data visibility on exactly what is sitting inside an inbound return box. These challenges are compounding rapidly due to the explosive growth of e-commerce, which has permanently driven up total baseline return volumes. Add to this the growing environmental, social, and governance pressures. To survive, industries are being forced to adopt closed-loop circular economies that minimize net new resource consumption. Successfully capturing value requires moving past reactive problem-solving. This means integrating reverse flows into the core design of the supply chain network. Remember the strict apex distinction. You must design the overarching physical and data system long before the discrete, event-based triggers occur. The taxonomy is clear. Returns represent customer choice. Recalls represent safety obligations. And reverse logistics is the system that manages both. Ignoring this structural reality leads directly to massive lost economic value, bloated handling costs, and elevated regulatory risk. But a well-designed, strictly controlled reverse logistics network does the exact opposite. It transforms a traditional supply chain cost center into a highly efficient value recovery engine.